Okay, hi everyone. We are here today to talk about the chapter 10. And I don't have any anything to talk today, just to start the study with Martin Stefanko and Marceline together again. And okay, let's go. Let's study the chapter 10.
Okay, so let's dive right in. There is quite a lot of things that we need to talk about in chapter 10. So hopefully you are seeing my screen. Again, if there will be any questions, just shout because I am on a single screen today. So today we are going to look at cloud native application patterns, which basically means like way how you can write your Java application or Quarkus application in a way that it acts nicely in cloud, more or less. Uh, Basically, what we are going to look into, and I can start showing you, is microprofile and small I. For those who don't know what microprofile is basically a set of specifications. They are like the same level of specifications as nowadays Jakarta EE or previously Java EE. Just microprofile was created to basically create specifications that aim to basically define these cloud native patterns. So you have like things like health metrics, observability, and these kind of things. Microprofile basically started in 2016, if I remember correctly, and originally it was only basically a subset of back then Java EE, and it basically took 4 or 5 most used Java EE specifications in code space, and that was CDI. Sorry, it's not here. Where is this? I don't see it. Oh, okay. It was, I remember, CDI, JAX-RS for REST and CDI for dependency injection. It was JSON-P and JSON-B, processing and binding. And I think that's it. So actually only 4. And of course, like interceptors and these like and injected, etc., which is included in the specifications. So that was microprofile 1.0. But very soon people realized that there is more potential, and microprofile, I think 1.1, which already introduced the first pure microprofile specification, which was config, was released, I think, like next year after that. Since then, in microprofile core platform, which in the book is 6.1, but we are already have microprofile 7 since then, contains 8 specifications in so-called core platform, and that's these 8. I'm not going to go over each one of them because we are actually going through them in the chapter. But there is also a bunch of these standalone specifications which are not part of, like in my case, microprofile 6.1, but there are like full specifications that you can, and actually all of them except for open tracing, which is already deprecated, you can use in Quarkus without no issue because we have implementations for them. LRAs, for instance, distributed transactions based on Saga pattern, GraphQL, we already saw in chapter 4. Context propagation is actually implicitly used all over the place, and I will show you when I will generate Quarkus application. Reactive messaging we actually had in previous chapter, so last week or 2 weeks ago. And reactive streams operators was basically chapter 8, which is just basically a set of operators on top of reactive streams. Okay, so basically small I mutiny in other words. Okay, basically Quarkus is fully compatible with microprofile now 7.0 or 7.1, I now don't remember. But the microprofile is only the specification. So basically, you have the APIs, interfaces, like some data classes, enums, etc. If you want to use it actually in Quarkus, you need to include the implementation of that specification, so implementation of the interfaces. And in Quarkus's case, this is called smallRai, which is its own project, which you can find on smallrai.io. Which is more or less always mapped one-to-one to microprofile specification. So if I have microprofile health, which will be the first one that we are going to talk about, then I have also smallRai health project. And smallRai health is just the implementation of microprofile health. this is important because in Quarkus, when you are including extensions, they are actually always called small right dash something or Quarkus dash small right dash something, not microprofile dash something. So just that you are not surprised when you will see it. And also, because this small is an implementation which we control, we are actually pushing a lot of innovations or experimental APIs in small projects, because we can basically user test the feature before we will propose or include it inside the specification. So if I will propose some API in small health, which like will take up and people start using it, then I have some like argumentation power to include in microprofile health where other companies can also chime in. Okay, so if there are no questions to this, we can dive into our, I believe, 4 specifications that we are going to talk about today, because I will just quickly say what we already saw. So we already saw OpenAPI when we were talking about REST. We definitely saw REST client in chapter 4 because we were talking about it. So you see that it's actually originally a microprofile specification. We for sure saw config since chapter 3 because actually Quarkus' configuration model is purely based on small config, which is one of the small projects. And I believe that we talked about JWT authentication, but we use OIDC in the book. But JWT stands for JSON Web Token, and it's just different authentication mechanism that you can plug into the same Quarkus security model as we had in chapter 6. Purposely, well, okay, we did GraphQL. Context propagation, as I said, is implicit. We did both reactive ones, and tracing we didn't do so far. LRA is not covered in the book, but if you would be interested, we can have like follow-up session because that's actually one of my specifications that like I really like to talk about. Okay, so moving on, monitoring application health. In any cloud environment, basically, when we are saying cloud, basically we mean some public cloud, which is more or less very often mapped to a Kubernetes platform or some flavor of Kubernetes, which means basically a fork of Kubernetes, like OpenShift, for instance. Sorry. Um, However, this is not like only in Kubernetes, but more or less, if I am saying cloud, I mean Kubernetes, because typically with Kubernetes you can deploy to any public or private cloud, and it always behaves the same. So it's typically to-go platform for most of the deployments, at least that I saw in real-world usage. So in this kind of environments, and now I will be saying Kubernetes and cloud interchangeably, you need to somehow provide the information to the platform whether your application is running or if it's functioning like as it should, because these platforms like Kubernetes needs to be able to detect basically any defects in your application in some standardized way. And in Kubernetes, this is done by so-called Kubernetes probes or health probes, which can be of 3 types, either liveness here, readiness, or startup. Liveness is basically really the most important one, because if your application answers that it's not liveness up, not alive, basically Kubernetes thinks that this pod, basically your application, is unhealthy, and it will kill your pod and start a new pod instead of it. So basically it will restart your application just because you will say that I am not alive from this liveness probe. Readiness is similarly either up or down. If you say down, Kubernetes will just prohibit any traffic going into the pod that responded down. So that means that readiness is more used in use cases where you have like third-party dependency, like database, which is for some reason you will lose the connection to a database. That doesn't necessarily mean that you need to restart your application. So liveness should still be up, because if you restart your application, your database will still be down. But you can respond down from the readiness health check. We will get to it. And Kubernetes will just basically hold up any HTTP request going into your application. So other instances of the application can handle it, which have like running connection to a database, for instance. And this can be like anything that you will define, as you will see. Startup is the last one, which was added actually like not so long ago, because of one problem that you will most likely never run into with Quarkus. However, it is covered by the specification. um, Basically, before startup, no, oh, okay, let me take it from a different angle. Startup is basically the original health check, which is basically okay when it's down and you are just waiting for the first up coming from this health check. When basically startup says up, then you will switch to liveness checks. So it's basically your guarding mechanism before liveness kicks in. And why this was important? Because if you have an application that is starting for a longer period of time, again, usually not Quarkus, you could have your first liveness hit before your application is fully initialized or even able to respond. And in that sense, basically, if you don't respond at all, it is treated as down. So Kubernetes would restart your application. And again, your application is starting. First liveness will come before the HTTP server is exposed, and it will restart it again. And you got into this infinite loop of restarts. So somebody came up with the idea to define a different health check. So now you are going startup down, 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 down until you are initialized and startup says okay or up, and then you will switch to liveness. In small I health, or in Quarkus small I health extension, we also have a bunch of different types, like for instance wellness, which is just basically any form of health check that you would like to use, because people were actually very much like interested in this kind of functionality also for their own needs. So you can imagine that that health check is usually, which I didn't say, exposed as HTTP endpoint. So even like different microservices in your deployment can call, like these health check APIs to get the information if something is running or not in the service that they are calling. So people were really interested in this feature. So we introduced like any custom wellness health check used for your use cases. Of course, you can configure wellness also in Kubernetes probes, but it's not its intention. And because after a while we found out that like one custom health group or like health type is not enough also for some use cases, we basically extended this to custom health groups, which you can define basically in any way that you want. There is a bunch of APIs, like even declarative or programmatic in Smallrai Health. However, basically you can basically expose any number of groups, and you can decide which health checks are belonging into which group, and then you have slash group, I believe, slash name of your group, which will basically only take the health checks in that group. I just want to stress out that these wellness and custom health groups are only in Smallrai Health. They are not in microprofile health specification. Okay, and with that, we can start today by generating new application. Again, Quark is just my, or Quark is my script, which will do Quarkus create up at the with my predefined stuff. So I will just do today, let's do chapter 10, because I am like very bad today with my brain. So let me open it in IDEA and run it in dev mode. What did I do? We'll go to press shift, put it to, come on, my computer is little bit slow today. So I already ran it in dev mode. So you remember that we have, hopefully this is big enough. If not, please somebody shout. Slash hello. So we just verify that we have our application running, and we will start by adding, so Quarkus extension at Smallrai Health. You remember that if I will add extensions in dev mode, it will automatically restart with my extension present. And what this extension will give you out of the box is a new endpoint on this /q subpath called health. which will basically provide you with the information about the health checks. Um, if we didn't say this previously, but I suppose we did because we for sure had run into it before, /q is a reserved prefix or subpath that we are using for Quarkus's exposed endpoints. However, it is customizable. So if you want this to be something else, or if you want it to be mapped directly on a root context, or even if you want to map all of this Quarkus's exposed stuff to different port, everything is possible and everything is configurable. This is just how we are handling the default. Okay, we will be calling that /q /something today a lot. So this health is basically the general health of the whole application. Everything that you have in your application, every health check that we will find is included in this health. Then you have, I'm starting. Health live for liveness, only liveness check, ready only for readiness check, started for startup checks, and I believe well for wellness, and group for health groups or health group / something, which would give me only health group something. This is again everything configurable if you want to. So uh, before, let me start. The easiest like way how you can contribute the health check is create basically a Java class. So let's call this whatever, test health check. I am not really good with names today, so we will be doing it like this, which implements this health check interface, as you can see, which is coming from Eclipse microprofile health, which has only one method, which is called call, and it returns this health check response, which is a health check response fluent API that you can use to build up your health check. The easiest way how I can do this health check is just by either app, which takes the name of the health check, and now if it's not enough. The other thing that you need to do is put one of the qualifiers, CDI qualifiers from the specification. So either liveness, readiness, wellness, etc. You will get the idea. And if you are not in Quarkus, you also need to define this as CDI bean. So either application scope, breakfast scope, or any bean defining annotation. However, in Quarkus, because again, build time magic, we can actually do this for you at build time. So in Quarkus, this qualifier is enough. And if I now call this /health, I will get my test health check in the response. So it's nothing fancy. I will just really quickly show you how to do something else. So if I would do named here, and I will put this to builder, let's put it like builder, and we will be returning builder build. I can do here random, and here if random next boolean builder up, else builder down. And now if I will start to call this, sometimes we'll get down, which is what I wanted to show. You see that if any of the health checks will give you down, the overall status of your application is down, and the return status code from your application is 503. If everything is okay, it's 200 okay. Otherwise, basically, this is what the Kubernetes can actually understand. So you see that if it's anything else than 200 of status codes, Kubernetes will, in my case, because this is now a liveness health check, if Kubernetes would call this health live endpoint, and now it returns okay, if it calls it and it returns down, Kubernetes will restart my application. Also, I can show you that if I would call now ready, because I only define this as liveness health check, it is not included in ready or any of the other checks. However, nothing is stopping you, I believe, to do this. Now I'm actually not really sure, but yes, it works. But I'm vulnerable, it'll happen like this. Yes, it will be included 2 times. Nice. Because it's actually like 2 different processing bins. Okay, so that would be more or less it. One last thing that we have also in the book. You remember that this terminal is interactive. So if I press D inside here, it will open the browser on my machine. And this more I held, where is it? Also comes with this like interactive UI, because inside this builder you can also do some with data. So I can actually like put a random data. So now if I will call this health check, you will see that I am getting like some data propagated in this. And yeah, that's nice that it's actually auto refresh. Oh, now it's down, but why I'm not seeing here anything? That's strange. That's strange. Let me try to because it's down. That's why, because it's down. And give me up. No, still not seeing anything. That's strange. Probably I cannot parse it for some reason in that, and that's actually something which I will probably need to fix tomorrow. That's good to know. Where is it? Where is it? I lost the dev mode. Where is the dev mode? Okay, so that's actually something that I will probably need to fix. But you believe me that it's there, but it's just like rendering issue in the dev UI. Okay, that would be more or less it. Before we will move on, I wonder if I can move this here. Uh, Actually, in Quarkus, if I would add, let me do JDBC Postgres. So I will add again Postgres and database into my application, of course. Oh, not QD, only QD. QD is again Quarkus dev, because I want to show you something. That if you have like any extension that is actually like usually connecting to some third-party service, like now I am connecting to Postgres, so I'm starting my dev service. You will see when it starts that actually the extension also can add this health check to your application. Typically, it's also configurable and you can disable it. But for instance, now it is checking that I have actually a live connection to a database. So if, and again, like only one of the health checks needs to be down for the overall status to be down, and you will get 503. So if I now, let me try to do Podman stop. Sorry, because my cat is making noises.
No worries.
Well, I am presenting from my home. So if I stop now this Postgres container, Podman PS, so I have no containers running, so my data source is not running. If I now try to call the health check again, you will see that the health check is actually down. And if I start it again, scratch it. Sorry. Start it again, my health check will be again up. So you see that like the extension can do this usually for you, and like MongoDB, Kafka, and this kind of like services, which are usually like providing their services because they are integrating with some third-party service. Usually they include also health check. Okay, so that would be more or less microprofile health. And you see it also in the UI. That's nice. Okay, so that would be more or less microprofile health. So if there are no other questions, this is more or less what is written in here, just in some like more complicated health checks, because they can actually be pretty long, sometimes surprisingly complex. Also in Quarkus or in small I health, you can write the health checks in asynchronous way with small I mutiny. So we have also async health check. There is a bunch of stuff in small I health which we cannot even possibly cover in the book. And why I'm telling this, because small I health is actually my project. Also, microprofile health is my project. So I kind of know it a lot. But let's move on. The next one is application metrics, which is another very important part in cloud native applications, because typically you are dealing with tens, if not hundreds, or even like more instances of your applications. And that means that if something goes wrong, it's extremely hard to pinpoint which particular applications did something wrong. So this is essential because you cannot possibly go and read the logs of like hundreds of applications, even like tens of applications is like a lot of time. It's basically essential to have some like aggregated way of collecting application metrics. In microprofile, there is actually a specification called microprofile metrics. However, in Quarkus, we are no longer supporting it. We also used to have a small metrics project, but that's already deprecated because we decided to go with a more broader initiative, which is called Micrometer, which you can find on micrometer.io. And it's basically library for aggregating metrics. It's providing a bunch of APIs, and it's basically just more popular than whatever microprofile metrics could achieve. Microprofile is also not only Java specific. I believe that they can do also different languages. So it's like just like broader initiative, and it makes sense for Quarkus to focus on that, not on something which is like standard, which is not really used. So we will be using actually Micrometer. In basically Micrometer, or like in general, metrics types can be on several times. So you have timers, which is just like timing whatever that you want. You have counters, which is basically +1 additions, which can only go up. This is important. So you cannot decrease the counter or like minus counter. Gauge, which is exactly that intention, which is like some numeric value which can go up and it can also go down. So it's very useful for any stuff which cannot be countered. And distribution summaries is more higher, like statistical probability stuff, where you get histograms and this kind of like more time related measurements, but it's not important like to really dive into specifics here. When you will need to learn it, you will find it. Each metric basically consists of several stuff. Like each metric needs to be like named, so it needs to be has a name. However, very often you will find additional like dimensionality key values or like keys in metrics, which we call tags in metrics. And these tags can be like whatever that you want, but they are always included together with the name of the metrics, and they uniquely identify a particular metric. This is particularly useful that if you, for instance, have like HTTP request metric, which can be, for instance, a counter, it will be like all the HTTP requests, or the number of HTTP requests that your application handled to the point where you invoke the metric. But very often you want to have like more granular view on top of like which particular endpoints has been called. So in Quarkus, or in like Quarkus micrometer extension, we are including these three tags like method, path, and status that was invoked. And then you can, for instance, get the like counter, like sub counter for all get methods, or all post methods, or all methods which were 200, or 404 or something like this. So you have more granular approach, and any we usually call it like a metric collector backend, which is usually a third-party application in our case, because we are including Prometheus more or less like all over the book. It's Prometheus. It's basically a query database, and in this query database you can actually use this text to basically filter the metrics for the particular like dimension, that tag that you want. Then basically the programming model is either declarative, so you have a bunch of annotations, which I believe that in Micrometer there is only counted and timer, but I might be mistaken, because this is like not something that I'm using every day. But in every case, you have access to all metrics with the programmatic API if you inject this meter registry, which is automatically provided by Quarkus extension. And then on this meter registry, you are just calling some methods that are doing your metrics. Okay, so let's move on. I will just save some typing and I will add Quarkus Micrometer Registry Prometheus to my application, which I believe doesn't have a dev service. I don't know, but I think that it doesn't, which I will check. And it doesn't. So I will need to run Prometheus, which is not something that I prepare for. Ooh, nice. I like it when I have actually something prepared, which I didn't know that I have it prepared, which I also need. I will copy paste from myself, so that's okay. It is nice. Nice. So what I did, I copy pasted this Prometheus YAML, which is just a configuration file for Prometheus, where you basically the most important stuff you need to specify how often, because in Prometheus actually calls your application to scrape the metrics from the application. So you need to specify the interval how often Prometheus calls your application, and you need to specify the actual targets on where it is actually performing the actual call, and also the path on which it is invoked, which is already giving you where the metrics in Quarkus micrometer extensions are exposed. So this is just something that I need after when we will be collecting metrics, but that endpoint is already exposed, and I can just call /q metrics, and you will see that I'm already like now in my terminal scraping the metrics from my application. So for instance, like if we take something system load average or system CPU count, so you see that I have 16 cores. I hope that is not private information. It's not enough cores though. I need more. Let me like grab HTTP. So we will see that HTTP. Oh, I don't see the requests. Connections. Well, let me try to do request. Oh, because I don't have any call to the application probably. So if I call my application a few times, I am getting now a more request, but I hope to find only one. But I have like this status. So we see that I called hello 3 times. If I try to call the no, like why is this not? Oh, because it's active requests. Okay, I'm too tired. Sorry. So we see that like that hello counter is getting up. If I call it again, I should get 4. Yes, so it is working implicitly. So you see that Quarkus provides a bunch of these metrics out of the box in your application. So let me just run the Prometheus. It's not important what am I running, and of course I don't have the image pulled because why I would. It is fast. So this will run Prometheus on port 9090. So this is Prometheus running in that container. And here, if I type HTTP, yeah, request second count, for instance, and type execute, we should see like, yeah, I have like 4/hello. And if I call the hello again a few times, and I will execute again, this is automatically collected. So this is how you will get to that individual metrics. And if I would know like how to, yeah, so it's in this. So here I can specify, for instance, method equals, oops, get. So this is how we will filter the individual, but of course I have only one because I don't have other endpoints. But this is how you can. These are the stacks, these dimensions that I was talking about. So these are the metrics, as you can see, a bunch of them automatically included in your application when you are starting. But you can also define a bunch of your own metrics, as I was telling you, either with this counted or timed, timed. So if I now invoke because if you will, all creation of these metrics is lazy by default. So if you will not call the metric, it is not created. So this is why I need to call it a bunch of times. And now on these metrics, if I will search for hello, I should probably get only maybe let me do uh, no, I believe that it should be. Yeah, method counted total. This is what I'm looking for. So this is that counted metrics, which you can see that is coming from my greeting resource. And yeah, it was called 3 times. So if I would call it again, and it would increase. Just for you to understand, this is like a normal CDI stuff. So it doesn't need to be an HTTP, JAX REST method or Quarkus REST method. This will work in any basically CDI bean. So you can trace basically your counts like throughout your application. However, also in any CDI bean, as I was telling you, you can inject this meter, if I can type meter, registry, and then basically you can do whatever you want. So with this meter registry, you have counters, you have timers, you have gauge, you have a bunch of stuff. And I believe that I don't need to go into details and showing you all of this because you can like experiment on your own. One thing which I want to show you, but I need to actually go to Quarkus.io because I don't remember. Quarkus GTM is that actually we have a dev service that works with all of this, and it's called LGTM, which is a Grafana stack. Grafana is a company that was popularized by creating a graphical software that can visualize these metrics. It was actually scraping very often Prometheus to basically just give you nice graphs, interactive alerts, and this kind of stuff. So they created this LGTM collector image, and we integrated it in a separate extension or in separate dev service dependency, because it's not really an extension, I believe, because it's not in the container. So now I can kill the manually run what I want to say, Prometheus, and I will just paste this wherever, doesn't really matter. Quarkus observability dev services LGTM, and if my application will restart automatically, you will see that it will take forever now to start, because it is actually going to start that very, very large container, which is called LGTM, Grafana Hotel LGTM. Come on. Yeah, this takes forever. But like, as any other dev service, once it started, your application restarts and the dev service is running. So it's pain only on the beginning. So now, if I check the containers, you will see that I have two of them. I have Grafana and I have Postgres. I will open again dev UI because like I could type that URL, but I don't really want to, because here I have in dev UI a button which I can click, because this will take me to port 45909, which is always something different. So I would need to like find it and type it, which I'm lazy to. So now I am already in Grafana, which is connected to my application. So if I will be able to search this, and I believe that this should work now, one of these, it doesn't. It doesn't. And I know because there is a
Did you
bug
make a
open.
request or not?
I believe I don't have to, because this is, oh, well, application was actually restart. So maybe you are correct. I'm not sure if this was fixed or not, because we actually had some issues with this. And it doesn't matter that much. I believe that I need this micrometer OpenTelemetry, maybe. OpenTelemetry is another project which is also doing metrics, but we are using it for traces more. But I believe that there is a bug with the micrometer pushing to that LGTM dev service. So let me try with this one. just we see something inside the dashboard. And of course, it needs to restart. I can take some questions before this will go up if somebody wants to ask something.
I don't have question.
Okay, so let me call it a little bit and go again, because now it started on different port, of course. So I need to click this again, and hopefully we will see something inside the dashboard. Now, come on. But I see already my application, so I believe that there will be something here in a while. Well, we'll try in a minute. But if I will go here to explore, I believe that I should have Prometheus here, and here I should see my HTTP or my method, count its total, and I can execute it here somewhere. I don't see execute button. Oh, I don't see execute button. I kickstart your query. No. When it's this big, I really don't see what I need to click. No data. What do you mean there is no data?
Maybe you can click in refresh, the blue button.
Oh, let me try with HTTP request. No, I believe that I'm just like missing something. Like I don't see something. Like there. Ah, there we go. So here we see it, and let me try with the methods. Count its total. And this one. Yeah, here we see it. So you see that I am actually pulling that metrics from that Prometheus, which is implicitly started within that LGTM stack, and I have it here. And let me try the dashboard one more, because I'm feeling, yeah, we have metrics. So you see that it works if you have that open telemetry. So we are already collecting a bunch of like pre-generated stuff, like because this dashboard is included in the dev service. So you see that you have a bunch of information already. So you have at least the idea of what you can get with that Grafana stack. So I wanted to show you this. And okay, I need to park this because we are running out of time, and we still have two more to go. So I will take this a little bit faster. So the next one that we want to basically, or we wanted to explain in the book, where is it? Here, is tracing, which is the basically the next big part of the observability stack, which is basically in observability, there are three main pillars or three main stacks that you are caring about in your application, and that's metrics, then tracing, and the third one is logs. All of them are out of the box, or like are defined in the project which is called OpenTelemetry, which is a CNCF project. And you can actually use all of the OpenTelemetry, including metrics, in Quarkus. This is what I actually added into my application. So I added the OpenTelemetry. Where is it? Oh, I don't know if I did it. I did micrometer OpenTelemetry bridge. So actually, I am still defining my metrics in micrometer. However, there are also translated into protocol which is called OTLP, Open Telemetry Protocol. So they are actually available here in this dashboard, which is called Microprofile Open Telemetry. And this Quarkus Microprofile registry, micrometer registry, is not working for some reason. And I remember that I talked to Bruno, and I forgot if I should have fixed it or he should have fixed it. So that's again something that I need to look into tomorrow. But at least you will see that it works if I will go into this OpenTelemetry. And this is automatically, like updated. So you see how much heap I'm using, and you see that it's automatically updating. Okay, so traces. Traces are actually very easy for me to Google, because as I told you already, in Quarkus, we are using OpenTelemetry for traces. So we actually already have that OpenTelemetry extension implicitly included with that micrometer OpenTelemetry bridge. So I should already be collecting traces, I hope. And traces, inside the book, we are using tracing backend, which is called the Jagger. However, in this OTLP stack, we have this, if I go to explore, we have this project, which is called Tempo, which is actually your tracing backend. And here I should have search, and yes, finally something works. We already have three traces already generated for us because we called our application 3 times. So if I call that hello endpoint again a few times and refresh this, we should be getting them very soon. Or maybe not all of them, maybe yeah, I have all of them, but for some reason I have only like three, but these are my three last. So if I go into this trace, this is nothing fancy. If you already saw like any trace in your life, you see that basically you have like how long the request takes, which all methods are being called. So if I would have, and let me do actually this, let me do this like this, and CP chapter R2 chapter 10 2 and 2, and if I want to run two Quarkus applications on the same machine, what I need to do? Change the HTTP port. Now I should be able to run the application again. Quarkus LGTM dev service is also configured to automatically. So if you have multiple dev modes running on the same machine, they will automatically connect to the same LGTM dev service. So at least I know that it will not start a new dev service, which was very fast. And let me really quickly in my first application at REST client. And in my first application, in greeting resource, yeah, let's first just create chapter client, which is REST client. Come on, idea, help me, I don't have time. Register REST client. This is already something which we saw in chapter, oh, what was it, 4? Come on. Hello, and get string hello, and this should be interfaced. I don't know why I clicked it plus. So now I should be able to press client, my chapter client, and here I want to do string result chapter hello, and here plus result. So now when I call my first application hello, oh, what did I forget? Who is paying attention? Uh, what am I doing? HTTP. Is it correct like this? I am. I forgot how to type URL. Ah,
It's double slash.
double slash like this.
Yes.
Sorry, I am really tired today. So now, hopefully, I am calling my hello REST endpoint again. And because they both have, because I just copy pasted the application, they both have the OpenTelemetry extension, and they are both connected to the same LGTM service. Now, if I, oops, okay, what happened? Let me open it again. I don't believe that my LGTM restarted. Don't tell me that the LGTM restarted. Where is it? What? What is happening now? What is happening now? Where is LGTM? It's here. Why it's not showing in the UI? What is happening now? Well, live demo. Because like it's taking me to a wrong URL. So here is some Grafana. Let me try to go to Tempo again. Search. Yeah, we have some traces. That's nice. So if I now open some trace, nice. At least it works. I don't know what went wrong in the dev mode, but now you see that from my first application, I'm actually making the call to a different application, which is nicely allocated in this graph. So here, if you see this down here, you see that I have, because this is extremely big now, I have my get slash hello to my chapter 2, and I have get slash hello to my second service, which should be somewhere here, hopefully. Localhost 8082 slash hello. So this is in the way how the trace works. So trace is basically nothing fancy. It will just basically put some token which is randomly generated to your first request, and that request that token is then propagated with every call throughout your microservices deployment. So in that sense, you know in which part of your applications or which instances of your applications handle the request. And of course, this also will carry the error back if there is some. Usually, you are not going to trace every request. Usually, there is some probability that will basically say if you are tracing or not, because this will add some overhead to the overall propagation because you need to handle the token. However, it's extremely useful when you need to trace like what is happening inside the system. And this API is also extendable. So let's say that somewhere here I would need to call long method. Oops. It doesn't need to return anything. And let's here just do some sleep. 200 milliseconds should be okay. Then I can do this. My cat is very noisy today. With this with span annotation, I can basically, again, in any CDI bean, define basically this step in my trace, which I forgot to tell you. Each of these line is so-called span, which is nothing else, just one step inside the trace. So you have this option to either do with span, or there is also a programmatic API. You can inject the tracer object to basically specify your custom steps inside the trace, your custom spans. So you can basically, if you have like more granular use case, this is how you can do it. If I now try to call my method again, what is happening? Oh, I don't know why I generated private method. Yes, it needs to be public because, of course, like we need to intercept it. So if I now call it a bunch of times, and I will move this back and reset this, hopefully this pen now. Oh, it does not. So let me try to do it again. Okay, so you actually see already this like trace or like this pen also here, but I hope to see it here. Nice. So now you will see that I have this like one beginning at the beginning, which is calling my get hello in my second service, and then I'm waiting for 200 milliseconds. You can see it here in this greeting resource call long method call. So this is how you can specify basically more granular approach. And you can imagine that when you will have a little bit more complex application, I think that we have it here, you see that like either even in our like free service call with user service propagating, we have already 7 spans. And 2 of them are in first service, 3 are in second service, and 2 back in the user service. So it can be pretty complex pretty fast. But this kind of information is essential in distributed systems, especially when your system needs to scale. Okay, I will park it here because we are actually running out of time and I still have one more to cover. And the last one that we will cover, I will go very, very fast because it's actually pretty easy, not to implement, but easy to use. And that's this small I fault tolerance. So extremely useful that I already have two services running. So in my first service, I will add this small I fault tolerance extension, which will restart the LGTM dev service, which is unfortunate, but we need to do it. And this will actually kill my application. So let me start this again because we need to have the LGTM dev service. At least I can drink some water. This will be pretty fast. Before we will get there, I will just very quickly explain what fault tolerance is. More or less, if you imagine in previous chapter when we were talking about reactive systems, we were talking about how they are able to handle failures, so they are not dependent on all services being always available, because the Kafka or RabbitMQ can actually buffer the messages. Typically, when you are using protocols which we had in chapter 4, so like synchronous protocols like REST, GraphQL, gRPC, they require like both the client and server of each of these requests to be up throughout the whole interaction. If the server is not up, your request will fail. And I want to demonstrate this. So I will start my second service. And remember now again that this terminal is calling this terminal. When I call this terminal from my client, this should be pretty fast. Come on. So if my second service is running, everything works. If I kill it, bam, you will put a very nice extension to your very not programmatic user. So it's usually a very good idea to handle this in some way. So if your application runs or it will start again, everything will work again exactly the same. But if you have a use case like this, that you are using synchronous protocols, we have this fault tolerance to basically help you with these use cases. It's not limited again to HTTP. It works in any CDI bean. However, it's just nicely showcased with this interaction with HTTP. So that small I fault tolerance, and I think that we have it listed somewhere here. We don't. That is unfortunate. So small I fault tolerance or microprofile fault tolerance will provide you with a bunch of annotations that you can again use in your CDI beans. The first one that I want to show you is this retry, and like I don't want to overwrite all the properties. Thank you. I don't have time for that. So this retry will basically retries the method which is annotated with it if there is an exception, basically. That's more or less what it does. So I can like do here max retries, and let me do like let me do 3 for the beginning. So again, if my service is running, everything works. If I kill my second service now, you will see still the error. However, let me do here. Atomic long counter, and let's just do here error counter. Come on, like this. I hope to see this here. You will see. Yes, you can see it actually here, but it's like really on the line that my method was called 4 times this time before it failed. So if I will, and let me actually do one more parameter here, which is delay, and let's delay this by I believe this is milliseconds. So we should see now that every second my method is restarted, and only after 3 retries it is failed. So if I change this to, let's say, 30 fails, you will see that now it will be retrying 30 times. And if I start my application in the meantime, and hopefully it will start before 30 seconds will run out. Come on. Come on. You see that call was basically on hold up because this was retrying, and after 18 retries it actually succeeded on a 19 retry, and it returned the response. So this is basically what that small right fault tolerance is doing. It will give you these APIs, and you have a bunch of these annotations. You have timeout also, I believe this one, timeout from org eclipse microprofile fault tolerance. I remember bulkhead, which is basic. Oh, timeout is only timeout. You understand that. Bulkhead is basically the limitation of the parallel executions of your method. So how many threads can execute this particular method at the same time. Then you also have circuit breaker, which I hope that I don't need to explain. This is like very general known concept. And last one, which I believe it's like one of the best, is this fallback, which basically will give you this. I forgot what is the parameter. Why are you not helping me, idea? What is the name of the parameter? Fallback method. Thank you. Thank you. Fallback method, which I can say here, my fallback, it doesn't matter. Which means that inside the same CDI bin, inside the same class where you are defining this fallback annotation, you need to define this exact name of the method, which has exactly the same signature as your original method. So public string my fallback. Now AI is helping. And this fallback will be executed whenever basically your whole execution of the method fails. Typically it is combined with something like retry or timeout, but it doesn't necessarily needs to. Basically it again will be invoked on any exception in this hello method. And here I can just say return this is a fallback. And if I now change this again to free because we don't want to be here till tomorrow, if my application runs, everything is fine. If I kill second service and try to rerun it again, it will be retried in a free. Come on. I don't know why it was retried so many times, but like, yeah, live demo. But you see that after it will run out of retries, my fallback is actually invoked. I really don't know why it was invoked 5 times. It shouldn't have been. Okay, I don't know why, but this is something that like I need to probably look into. So this is basically, I believe, the most useful annotation, because you can imagine that, for instance, you have a website for cinema, which is calling a different microservice, which is providing you with movies or like recommended movies for the user when they open the site. If this recommendation microservice is down, you can try 3 times. If it's still down after 3 tries, you can just give it like 5 movies which are most popular this month as a fallback. So this is extremely useful functionality. Also, if your method is taking, for instance, too long with the timeout annotation, timeout, which one this? I can say 100 milliseconds. Let me do 10 milliseconds. Now I shouldn't even retry, I believe.
Do you need to manually ensure the method is safe to retry, or does the transaction manager handle rollbacks automatically before the retry?
The transaction? So,
Yeah.
sorry, I didn't catch the beginning of the question. The transactions should be handled automatically in the background because, like, this is implemented through the same mechanism as at transactional. So the number of these interceptions is actually defined by the priorities inside the implementation, and I believe that the transaction should be like yeah, less priority than this one. So like the retries should be always executed within the same transaction. But I am not like 100% on that, but I believe that it's done this way. Okay, so that would be more or less fault tolerance, because that's again just like you playing with it. One thing which I don't have time to do, but I will show it inside the book, I hope. I am not. We don't have it inside the book. Oh my god. Okay, so we don't have it inside the book. However, you don't need to hard code all of these values inside annotations. They are, all of this is actually configurable through microprofile config or through Quarkus application properties. So you can like literally say somewhere in greeting resource, hello, retry annotation, change max retries to 30 in some like environment. And this is normally overridable through normal configuration means. So for instance, if you have like a region in your cloud where you know that it usually takes forever to call something, you can change the retry policy only for that region when you are deploying the application in that particular part.
Oh, see.
Okay, so that would be more or less it, because we have also here a mention about service discovery, which is included in project which is called Small Rice Torque. I don't see where it's written here. Somewhere here there should be like Small Rice Torque link, which is extremely useful when you are not in platform like Kubernetes, because you can use like normal service discovery mechanisms that you are probably using already, and they are very nicely then integrated into Quarkus. However, in Kubernetes, which we are going to use throughout the rest of the book, there is a built-in service discovery, which is actually also included in Stork. However, because Kubernetes is handling it out of the box, we don't need to include Stork extension explicitly. Only if you would need to have like some higher how to put it, you have like higher expectations or requirements on the how the actual distribution of requests is going through the discovered services, because Kubernetes will give you basically only the basic round robin, so it will go one instance after each other in a round, in a circle. So if this is not enough for you, then you can use Small Rice Torque. However, purposely, because we are already over the time, I will skip it for now. And that would be more or less it that I want to show today. And if we cycle back, you see that we covered telemetry, because this is Open Telemetry traces, Open API we had, REST client we had, config we had, fault tolerance we covered. Metrics are now included in Quarkus micrometer extensions or Open Telemetry metrics if you want to. JWT authentication is not that important because it's just one option that you can choose for. Health we covered. And except for LRA, we had these four already covered previously. Open tracing is purposely no longer supported in Quarkus, because Open Telemetry is actually a CNCF project that was created by combining Open Tracing and Open Console, if I remember, like 3 or 4 years back. So microprofile Open Tracing is actually deprecated in favor of this microprofile telemetry, which is just specification integrating Open Telemetry in microprofile. So you see that we covered almost everything except for distributed transactions, which is like topic for more than 1 hour on its own. So we covered basically everything that you have as cloud native APIs for available for you in Quarkus. Next week, we are actually going to take these applications where basically in the book we included all of this functionality inside the inventory service, because like more or less this is the like rinse and repeat in every application that you are going to write for cloud. So we are purposely just focusing on inventory service, so we are not doing the same stuff all over the place. But next week we are going to actually take all of these applications First thing, we will try to run, and I believe that I will do this inside the book. We will run the whole Carental application in production mode. So we will move from dev mode and all of the very nicely and very easily run dev services to actually running all of the current services with Java minus jar and running the whole infrastructure manually in containers. This is what we call production mode. Then we will put even Quarkus application into containers. So we will have our 5 applications push in remote registry. Then we will take all of these, I believe, 17 containers, and we will deploy them either to Kubernetes and OpenShift, but I believe we will have time only for one, so I will take probably OpenShift. And if we will have time, I will show you also how to create a serverless application with Quarkus, which we actually then also include in Carental, but it's not that important. And basically, I believe that we can finish the next chapter when I will deploy the whole Carental application with the whole infrastructure through probably the easiest mean that we have in Quarkus. And at least you will see how easy it is to deploy to these platforms. Okay, Mateus, I believe that's everything that I wanted to show today.
Oh, great. Thanks a lot for this knowledge. And I think I don't have question. Marceline, do you have any question for
No, I
Martin?
haven't.
Okay. And thanks again, Martin, for your time, for your knowledge, with sharing your knowledge with us and with YouTube. Then, if you are learning through YouTube, uh, join us in the next Wednesday in the same time, 5 p.m. here in Brazil, -3. Okay, and let's go to the chapter 11. Great, thanks a lot, and bye bye.
Thank you, guys. See you next
Thank you.
week. Bye.